Okay, so in this one, what we would like to go over is the journey of the computing world has taken from 1960s or 70s till now. And our hope is that when we trace this journey, we would sort of uncover, certain topics along the way, and uncover for the later topics which we're going to discuss and their motivations behind those. So with that in mind, let's see, what very briefly what a computer would have looked like in 1960s. So with the advent of transistors, yeah, the computer industry boomed, and we had this big giant room-sized computers which were just equipped to do some very tough calculations, which humans would take roughly, like a day or so. Computers would do it in minutes time. All right. So at that point, the model was very simple. It had some memory which the computing unit could access. So yeah, there is a memory block, and then there is a CPU block which your computer could access, and there would be some lines here and there, maybe interrupt lines, some address lines, data lines, and so on. And the layout was very simple. You just write your code in like basic zeros and ones, literally, which are transcribable by the CPU. So it can understand the meanings of zeros and ones. The code would be there, the data which it needs to process would be there alongside it. And if you remember, Piyush, I think you might know the journey where the zeros and ones would also be sort of punched over a card. So there would literally be a
Right, the punch card.
punch card where a hole would mean 0, and if there is no hole which is not punched, then it would mean 1. And basically a laser would be passing right through, laser and a receiver, and if it detects like, hey, I can pass the laser through because it's not blocked by the, or rather there is a hole in it, it would
But
detect it as
instead of laser, let's reword it to be a
a light
light
source. Yeah.
beam, just because that makes life easy. In fact, there was also the rotary,
Wheel sort of.
wheel or switches.
Hmm.
In fact, Mohammed, as we complete, uh, you know, let's say your part of the story, I want us to kind of revisit and talk about an important concept, which is that of ISA.
Right, and let's do that. Do you
Yeah,
do you
go
think
ahead.
it is a good time to do it right now or maybe later?
Oh, go ahead. Maybe complete your thought, and then we
Yeah.
can then talk about.
So at this moment, the CPU is just CPU, or rather the entire system as a whole, is just equipped to do one job, and that job is transcribed in the card which is fed to it. This uh, punch card, what they used to call it back then, and that punch card would have like a very simple calculative job for the computer to be done. For example, for a very crude one, let's say count, or rather calculate the digits of a pi, of the value pi up to, let's say, some decimal places, right? So calculate 1,000 uh, digits of pi, and that's it. The CPU would then take in, process the code which was in the form of zeros and ones, and then emit the answer uh, on some, I think, printer which was connected back then.
Right. That is true. So
Right.
either a printer or you would have light bulbs
Light bulbs, yeah.
that would glow and convey again the answer as zeros and ones, and
Hmm.
then people would write it down on the paper as to what it meant.
And then they would again translate it to what those light bulbs would
Hmm.
mean in human readable form,
Hmm.
something like that, right? So the key point which I want to drive home here is that the CPUs were just equipped, or designed rather, to do one job. They would do
Correct.
certain job. Once it's done, they would halt their computing, and then some actual human worker would have to then get a new job, new punch card, so to speak, and feed it again to the machine, and it would
Right.
again do the next job.
Right.
Okay, so that is the main point I want to drive home. And here, let's say if you have like, and in fact, why they were called batch job systems was precisely because if you had, let's say, and these were mostly, in research, computers back in time were just
Hmm.
used or limited to research fields, right? Some, because they would require some heavy calculations.
Correct.
Suppose.
And the time on a computer was precious.
Precious, yeah. It was worth its time in gold, sort of.
Right.
So what would happen is, I, as a researcher, would first ask for a time on the computing system. I would write the code, make sure it's completely zero
Hopefully
bug
bug-free.
free, yeah, and then assign that card to the system manager there, and they would have, like, let's say some hundreds of jobs lying around, and when my time comes, they would punch the card in, get the results, and then few days later I could get the results of my computation. So
Correct.
yeah, this is what the system used to be for
Hmm.
like decades in
Right.
70s.
Right. And then let's do one thing then. Let's summarize what we have, talked about so far, and then let's jump into the CPU and what it is and what
Right.
people can
And
imagine.
maybe you can add the ISA part there.
Yes.
Okay.
And I think it's a good topic for a separate lecture. So maybe what we can do is summarize what we have discussed and then jump on to the next lecture.
Yeah, makes sense. Makes sense.
Okay.
Okay.
Go ahead.
Uh,
Go ahead.
so summary is like just 2 point concised one. One is that CPU there, or rather the computing element. I don't want to call it a CPU because it might be confusing
Hmm.
with the current CPUs, right? So the
Right.
computing element back then in 70s were equipped to do just one task. You feed that input and the data and the code, whatever you call it, in that some format, which was punch cards back then, and it would emit the answer after it's done computing, and that's it. It would just hold after that, and there was like a human involved to basically switch between multiple tasks. Once one task is done, they would uh, insert another job for them in terms of this punch card, and computer would start, and they would basically kick start the computing again, and they would get the results after that. So
Correct.
that's what the model used to be back in the day.
Correct. So, Mohammed, the first part was the computing element could only do one task. What was the second one?
Second one was that in order to the computer, that's what I want to highlight, which I don't think it's a major one, but still
Hmm.
needs to be highlighted, is in when computer used to switch between from one task to another, it would be a complete reset for the system. When you insert the new,
Mohammed, your voice is not clear, at least to me.
okay, is it better now?
Yeah, it is. It is better now. Could you repeat?
Yeah, sorry, I'll repeat myself. So the second point is that when the job bit from one card to another card changed, it would essentially be a reset for the entire computing system. So your
I see.
memory
I see.
would get wiped out, all the state would change. There would be nothing of the past job which would affect your current one.
Right. Right.
Hmm.
So essentially, the system would be shut down, let's say, or reset.
Reset.
New program be
New-
loaded into it, and then it will start.
Precise,
Okay.
precise.
Fair. Fair. All right. I think this is a good conclusion to the current lecture, which is some history and some imagination as to how things were in 1970s. All
And
right.
sorry, I would like to add
Go
one
ahead.
thing, just this sort of a note or a disclaimer. So for the folks who are wanting, very keen to get onto the juicy part, believe me, at least this has helped me and Piyush very personally. That if you trace back the history, you sort of understand the motivation, and if you
Right.
understand the motivation, the concepts later would just stick. It would naturally
Right.
make sense.
Yeah.
So you wouldn't have to go few months later saying, hey, why it was needed, I don't know, because you would actually have absorbed or soaked the motivation right here.
Correct. Correct. Yeah, and knowing the history kind of can actually help you remember a lot of
Yeah.
things. A lot of reasoning becomes easy. A lot of concepts just make sense.
Mhm.
So I think it's a good thing to know the history. Yeah, cool.
All right.
Anything else that you want to add?
Nothing on this
All
one.
right, perfect. So maybe then we'll stop this lecture here, and as part of the next one, let's dive into the components of this system, and with a specific focus on the CPU and the memory.
Yeah.
All right. So with this, we will catch you in the next one.